can see your bitch ass.
All right, this is the lab basically we are going to do today. Okay, so this is the bending of light. All right, so this is the lab, as I mentioned today, that we are going to talk about this lab. Okay, so before starting the lab, let's try to talk about the lab manual that I uploaded for you guys to your team. When you write the lab report, this manual will help you. All right, so let's try to talk about this. Can you guys see the word file that I'm showing you? Anybody confirm me that?
Yes, we see it.
Sorry? You can see, right?
Yeah.
Okay.
Yeah.
All right. So this is lab number 9, Lab number 7, that is, the due date today, as I mentioned earlier. The lab number 8, that is called bending of light. All right. So bouncing of light, that is the reflection, and bending of light, that is called refraction, right? So basically, that refraction lab we are going to do today. Okay. So what is the meaning of refraction? As I mentioned during the lecture time, refraction meaning light has to pass through the medium or mediums. Okay. So when light is passing through mediums, then what will happen? Bending of light or diffraction will happen. All right, or refraction will happen. Reflection and refraction. Refraction when it's passing, reflection when it is not passing, when it is bouncing off, right? So that's the idea. Okay. So objectives, you need to write down the objectives. When you are done the lab, then you will understand, what kind of objective you are trying to do. Okay. So basically, you are trying to measure the index of refraction of the medium. So two mediums we have. One is the glass medium, another water medium. So you need to measure the index of refraction, all right, those two mediums. So that's the lab basically we are going to talk about. All right, so let me try to, okay, so what we are trying to do, we are trying to measure the index of refraction of water media and also glass media. Okay, so how do you calculate that? That is the experiment basically we are going to do. So conceptual part is describe quantitatively and qualitatively the path of light follows as it passes through one materials to another, right? So how light is passing through one material, meaning one media, another material, meaning another media. So when we are talking about media, it could be considered, maybe three things. Air is one media or one material. All right, it could be glass, the harder material, or it might be water. These are called materials, you can say, or medium, you can say. Okay, so that is the conceptual part. You need to understand that how light is passing through it. Okay, now this experimental thing basically we need to follow something called Snell's law, as I mentioned. During the lecture time, Snell's law basically the sine of the angle of incidence divided by sine of angle of refraction, which is equal to, all right, index of refraction of that medium, index of refraction of the other medium. So that is the way, all right, Snell's law is working, right? So we are trying to use the Snell's law, all right, to calculate the index of refraction of any medium. All right, that's the whole point. That's the experimental part. Now let's try to talk about the background a little bit. So during the lecture time, I mentioned one thing, that index of refraction, which is n, in this particular case, n, all right, can be defined as the ratio of two speed of light, all right? So speed of light in general, that we all know, speed of light, all right? If light is coming from sunshine, or light is coming from any light bulb, all right? That is the speed of light, right? So what we are trying to do here with this definition, with this equation number 1, that n is the index of refraction that we are trying to calculate. And how do you define that index of refraction? It is the ratio between two types of speeds of light. When it is coming in, all right, the speed of light, which is same as the speed of light, which is 3.00 times 10 to the power 8 meters per second. We all know that. And the speed of light when it passed through the material or passed through the medium, all right? These two lights, when you are making the ratio, whatever value you get, that is basically the index of refraction, okay? Now, in this case, V, or you can say C, whatever. So that's V is speed of light inside the medium when it is passed through. And C, when I'm writing, that is the normal speed of light. We all know, you, me, everybody knows, all right, as I mentioned earlier. So this is the index of refraction that you need to measure. And this is the way we can define it. Next is Snell's law. All right, Snell's law basically describes, all right, as I mentioned earlier, if you have the index of refraction of any media, which is N1, and theta 1 is the angle of incidence of that media, that has to be exactly equal to index of refraction of the second media where light is passing through, all right, and sine theta 2. Theta 2 basically is the angle of refraction. You guys need to remember, so during the lecture time, I mentioned that one. So theta 1 and theta 2. Theta 2 is the angle of refraction because it's passing through, all right, or passed through. And theta 1 is the angle of incidence, okay? So if I show whatever I'm saying here by a picture or diagram, then I can say this way. So this is the one medium, all right? So let's say N1 is the one medium, index of refraction is this much, N1. And another medium, index of refraction is N2, all right? N1, N2, two different mediums. And when you have two mediums, then you have to have an interface, all right? Interface, all right, is the boundary. If I say boundary, all right, that boundary, basically, when you have two mediums and those two mediums connecting to each other, then boundary will be created or interface will be created, okay? So that interface, all right, and when light is hitting, then light will decide whether it will reflect or refract. Reflection can happen if this surface is very smooth, like a mirror, then reflection will happen. And if that, the interface is not like a mirror, when I'm saying mirror, then other side will be coated, right? So if it is not coated, if it is a glass piece, all right, the second media, then what will happen? Light will diffract rather than reflect, all right? So when light is passing through it, then they are making an angle with the normal. So this is dot line is the normal, and theta 2 will be created here. So theta 1 is the angle of incidence for one medium, and whatever medium it could be your medium, or it could be whatever medium, okay? So N2 should be different medium. It cannot be same medium. If it is same medium, then theta 1 and theta 2 should be same. But it cannot be same medium. So it has to be different medium. So when it is different medium, then angle of refraction should be theta 2. So theta 1 and theta 2. How did I define it? You need to understand that, okay? So when you got the theta 1, theta 2, then using the Snell's law, what we can do, we can write this way. So sine theta 1, which is equal to N2 divided by N1 sine theta 2. So this is the formula we can write very easily. Equation number 3, okay? Now, in this equation, all right, one thing should be known, all right, that I'm going to talk about later, but just try to remember this formula, all right? So equation number 3, this is very important. And when you are calculating this equation, then you can measure whatever index of refraction you want. Okay, so N2 divided by N1, this is the ratio. All right, basically what will happen if you plot sine theta 1 value and sine theta 2 value, then you will definitely get a straight line, and that straight line will give you a slope. What is slope? Slope is a straight line, all right, and that slope will give you, if you, I think everybody took math, so m is the slope, which is equal to y over x, right? So using that formula, then you can calculate n2 over n1, and that should be the slope. Okay, so that I'm talking about n2 over n1 slope, and that slope value you can measure if you are fitting the curve. How do you fit the curve? I'm going to talk about that just in a minute, but I just wanted to make sure that. So when you plot your theta 1, sine theta 1 and sine theta 2, then you are going to get the slope of that plot, and that slope should be exactly equal to n2 over n1. All right? So from there, you can calculate whatever index you are trying to get. You can get it very easily. How? In details, I'm going to talk about just in a minute. Okay? So this is the data table you guys need to use. All right? How do you collect the data? I'm coming there. All right? So when you need to collect the theta 1, you need to collect theta r. Theta r or theta 2, same thing. All right? So if you replace this one as a theta 1, as I mentioned earlier, theta 1, it should be fine. Okay, so theta 1, and this is theta 2. Theta 2 meaning angle of refraction, okay? So, okay, theta 2. Okay, so theta 1 in degree, theta 2 you can measure, and then take the sine of theta 1, all right? Sine of theta 1 and sine of theta 2 according to this figure, right? According to this figure, you can write it this way. So theta I meaning incident, right? R meaning reflected. That is the way you can name that one. So what I'm trying to say, theta 1 basically should be the angle is right here, and theta 2 the angle inside the medium, right? So that's all I want to make sure. All right, so this is the data table you need to follow, and when you get this data table filled with the data, then sine theta 1, sine theta 2 you need to plot. How do you plot it? So just sine theta 1 you need to plot here. Again, theta 1, sine theta 2, your y axis. So sine theta 1 should be y-axis, sine theta 2 should be your x-axis, and slope, all right? So, if you plot it, then you will see it is a straight line, no doubt. When you have a straight line by axle, there is a fitting, curve fitting, this is one option you find, and if you press that option, then that is going to give you m value. That is the slope of that straight line. You can find it, and that slope basically y over x. So this is your y value, this is your x value. All right, so let's try to correct it. So you guys understand, this is 1, this is 2, right? So then it should be exactly equal to n1, n2, right? So this is the way you can get that value, n1 value and n2 value. And what kind of medium you are talking about? One medium's refractive index will be known, and then other one you can, you can measure very easily. So this is not 2, this is 2. Okay. So N1, N2, this is the way I can write. So what you need to do, you basically need to measure the unknown medium's refractive index. You have to have a known medium with a known refractive index, and you are trying to find out the index of refraction of the unknown medium. Okay, so that is the job we need to do today. So let's try to go back to the experiment. Before going to the experiment, now, do you guys have any question at this point? Do you understand what you are trying to do, or what we are trying to do here?
Everything you just explained is what they just data. The data.
Yeah, so we need to collect the data. How do you collect the data? All right, that I'm going to show you just in a minute when I'll open the simulation software. But before opening that, so whatever I talked about so far, do you guys have any question on that, or you guys are okay?
For the graph, do we still get it from Excel like we've been doing?
Yeah, so we need to use Excel. Okay, so I'm going to show you for one how to collect one set of data and how do you conclude that one from there. So I will go through it, and you guys need to follow it very closely. So you need to do the experiment, and you have to create another set of data, all right, by yourself, everybody. Okay, so let me try to do it, that part. All right, so this is the data table basically we need to fill out. Okay, and how do you fill up this data table? And after filling up the data table, then you can make the graph very easily. It should not be a problem for anybody, I guess. Okay, so let's try to do that. For that, no matter what, we need to open an Excel file. All right, we all know that. So Excel file, try to get ready with that. And with this Excel file, if you want to write down, let's say, theta, if you write down with a symbol, you can do it, but you can write, let's say theta 1, okay, by symbolic. I wrote it down here, so let's do it this way. Theta 1, okay. So this is the angle of incidence I'm talking about, okay. So just, I'm using the symbol, all right. Let's do it this way, PHP. Theta, I wrote it down, PHP, theta 1. And let's say theta 2, okay. Now then sine theta 1, right? You guys understand, right, what I'm trying to say? Sine of this theta 1, and then another sine of theta 2, right? That's the data table we need to create. Okay, so let's do it this way. Okay, so okay, theta 1, theta 2. Okay, so let's try to save it somewhere. Okay, if anything happen. Okay, so this is the data table I just got ready, and now let's open the software. Okay, that we need to use. Okay, so this is the software. So you guys need to familiar what's going on with the software. So in this experiment, no matter what, we need a laser or light, right? So this is the source of light. So look at this. This is ray, this is wave. So we don't need wave. That will confuse you a little bit. So do not use wave, just use the ray. Okay, so let's say I choose ray, all right? And right hand side, these are the two mediums. Okay, so this is one of the medium. It said here material. Material basically, it could be air, it could be anything, all right, as I mentioned earlier. This is one of the media, and this is the another media. So look at this, this is the white color, and let's say this is the air media I'm talking. So if you change the knob, you can change the media. So now I am choosing air media, all right. Now I can change that air media to water media. This is water media, all right. Or I can choose the glass media, something like that. So one of the one of the three medium we can choose, all right, from part 1. And part 2, same way, I can choose air, I can choose water, I can choose glass, okay? So these are the two things. So when you change it, then custom media you need to use, and you can change it without any trouble. So for example, now we are thinking one medium, for example, is air medium. So this medium will be considered as a air medium. And let's say this medium I'm talking about, let's say water medium. So two different medium, right? So two different color you can see, right? So this is one of the medium, this is another medium. Two different medium. Now this is the laser, I get ready with that. This is the laser, all right? And this is the normal I talked about, that normal is a perpendicular line on the surface. Okay, so this is the normal I have. Now this is the laser, and there are some instrument right here. I'm going to talk about that just in a minute, but before that, let's turn on the laser. Okay, when you turn on the laser, then what you need to do, you need to press this one. This is the laser I turned on. Okay, now look at this here. Okay, so this laser you can change the angle. All right, you can do it. So this, if you set it this way, that means laser is passing through the boundary very easily. Okay, now if you change the laser, all right, perpendicular, so the laser is falling just 0 degree angle, right? All right, to the normal. All right, so that way you can measure the angle. Now look at this. When the laser, you are turning on the laser, when you did, then what will happen, some of the laser reflected, partial light will be reflected, because the water and glass media, somehow the laser is filling, so this is somehow glittering. So that glittering basically will give you some sort of reflection in this case. And most of the laser will pass through it, because two different mediums. However, this medium is water medium, so this is transparent basically. So when it is transparent, then obviously, light will pass through it. But if you are using a glass piece here, or mirror, then what will happen? You will get 100% reflection rather than refraction of light. Okay, so this is the way it works. So if you want to change it, you can change it this way, as I mentioned earlier. The arrow sign, basically, arrow sign towards that way or this way. These are the two options you have to move, all right, your laser. Okay? You cannot do anything else. So this is the one thing. And the second thing, whatever I have here, let me try to bring that. So this is the protector, all right? One of the protector, I can bring it here. So you guys know what is protector about. So when you are trying to measure the angle manually, then this device will help you, right? So protector, I put it here. What is the reason to put the protector here? Because I need to measure the angle of incidence and angle of refraction. Okay, so that's the whole purpose. Now, when you set the laser, try to make sure, so this is a vertical line here, right? That vertical line has to match with the normal, okay? And this line, this horizontal line, has to match with the boundary or interface. If you are not doing it properly, then the angle that you are measuring, that should be totally wrong. And that is going to give you wrong result, okay? So when you, adjust it, try to adjust it as proper as much, all right? So this is the protector. I set it here to measure the angle. Now what will happen, all right? Now you can change the angle very easily, okay? So change the angle very easily. So as we are concerning about the measurement of index of refraction, so that reflected ray, we are not focusing that much. So because we are focusing, by reflected ray, we are not considering, because it is the partial reflection. So that is not going to help us, anyways, okay? So we are not focusing that. So do you guys have any question up to this point? Everybody's okay? Chantal, you are okay?
Yes.
Okay, Kayla, so far so good, or you have any questions? Good?
Good.
Okay. Kelsey, you're fine? Good? All right. Mesa is okay?
Yes.
Okay. Nathan, you okay?
Yes, sir.
All right. Ryan, any question for me?
No, I'm fine.
Okay, good. And Chandra, you're okay?
Yeah, I'm good.
Okay, all right. Because, these are the vital things, if you have any kind of confusion, then when you do the experiment by yourself, then it would be a problem, okay? So that's why if you have any question in your mind, please ask me so that I can clarify that. All right, so this is the situation. Now you are trying to measure the angle of incidence, which is right here. This is the angle of incidence, right? Now, how do you measure it? So when you, when you charge the laser, when you turn it on, okay, so turn it off. When you turn it on, then laser is passing through, right? So this is the incident ray making an angle with the normal, right? So basically what we are trying to do, I'm trying to measure the angle right here. So think about this way. What is the angle right now, all right? How much angle of incidence I have, and how much angle of refraction we have. Is there anyone who can give me that number? How much is your angle of incidence? So how do you measure the angle of incidence? This line and the normal, right? So this angle. So how do you measure it? How much? 30, okay, so let's say 30, okay? So you can measure it precisely, but let's do it this way, so 30, okay? So approximately 30 degree, that is the angle of, this is the angle of, what is that? What is this angle? What is this angle about?
Incident angle.
Incident, correct. And what is this angle about?
Refraction.
Yes, angle of refraction. So angle of incidence here, angle of refraction here. Okay. Now, so as Nathan mentioned, that this is the 30 degree of angle of incidence. How do you measure it again? So you can, read, how many divisions you have. So think about this way. So your starting point is right here. Okay, starting point is right here. So you are always measuring angle with the normal and the incident or refracted ray. Okay. Now, from here to there, look at this. 1, 2, 3, 4, 5, 6. 6 divisions you have. And if from here to there is 30 degree, then 60, each division how much, angle? It's 5 degree, right? Does that make sense? So 6 divisions you have, and each division 5 degree. So as each division 5 degree, so when you are measuring the angle, so try to make sure that, right? So sometime, you have to guess certain number, because no matter what, there should be some sort of error. But if error is 100%, then it doesn't make sense, right? So if error is 10%, 5%, 10%, it should be fine. Because when we are measuring that, so we don't have any digital meter, so we have to measure the angle by our eyes. So no matter what, some error must be there. So don't worry about that error. But that error cannot be more than 20 degrees. Okay, it's 20%, not biggie, 20%. So if it is more than 20%, then all of your results will be different. Okay. So what is my point here? Then, if I put my laser right here, for example, right here. So how much angle of incidence we have? Let's say we need to count it 1, 2 divisions, right? So 5, 10 degrees angle of incidence. At the same time, look at this, how much angle of refraction we have. Angle of refraction we have, for example, this is 5, and this is 5, half, so we need to guess this area. So 5, let's say, very close to 5, so let's say, 3, 8 degrees. All right, 8 degrees. Now, one thing you have to remember, the angle of incidence an angle of refraction should be always slightly smaller number. Why? Because of the bending, right? So if you are getting the number here, whatever it is, it should be slightly smaller number here. Okay, that's the trick, okay? So here it could be 4, it could be 3, that part, you need to guess a little bit. So I would say, 4, I could say 4 degree, that means 4 plus 5, 9 degrees. Here is 10 degree, here is 9 degree, I can say that. Or you can say 9.5, or you can say 8.5, all right? So that part is you can compromise that part, okay? So error should be there, but not too much, as I mentioned earlier. So my point here, for example, you have the angle of incidence here is 10 degree, and angle of refraction is, let's say, 9 degree, all right, or 9.5, whatever. Let's say 9 degree, okay? 10 degree versus 9 degree. Let's write it down. All right, so let's say angle of incidence is 10 degree, and theta 2, that is 9.1, for example, okay? So this is your first data, okay? So let's put it here. Let's try to move this one slightly more. Let's do it, all right? Let's do it here, okay? So how much angle of incidence? 5, 5, 10, or 5, 15, 15 degree, okay? So let's put it here, 15 degree. The second, 15 degree. And how much is the angle of refraction? We need to measure that, all right? So let's look at here, all right? 5, 5, 10, 10, and let's say 1, okay? 10 and 1, 11, right? Let's say 11 degree, okay, for example. Let's say 15 and this is 11, right, degree. So theta is measured by degree, right? So please try to make sure that is in degree, right? That is in degree, okay? That is in degree. That is in degree. Okay. All right. So the second data point I got, which is 5, 15 angle of incidence, and 10, 11 angle of refraction. So let's try to move it a little bit more. Let's do it here. Let's try to count how much angle of incidence we have. 5, 10, 15, 20, and 25. Okay, let's say 25 is the angle of incidence. Let's say 25. And angle of refraction, we need to measure it. And how much is angle of refraction? Let's try to do it. 5, 10, 15, 15, and it's not 20, it's a slightly less than 20. Let's say 29. Okay, so let's say 29. No, did I make a mistake? Just double check. Okay, so this is, am I doing the correct thing? Yes, this is 25. Okay, this is 25, and let's do it here. So 25 and 5, 5, 10, 10, 15, right? 15, and this is 15, let's say 20, okay? 20, 30, no, 5, 5, 10, 10, 15, 20, right? 25, 30. So this is 1, 2, 3, 4, 20 degree right here. So 20 degree. So 25 is there, 20 is here. All right, let's take another reading, exactly same way. So let's do it a little higher angle. Let's do it 60 degree, okay? 60 degree, all right? The last reading, let's say 60 degree. And let's try to find out the angle which is right here. All right, so up to here is 30 degree, 35, let's say 41. I would say 41, okay? You guys should have good eyes. You can do it better. So in my eyes, I can see 30, 35, 40, and slightly up, that is 41. Okay, let's do it 41. Let's do it 41, okay? So let's say 1, 2, 3, 4 data points I got, okay? So you guys need to do more, okay? So maybe 10 data points if you take, that should be better. If you take more, that should be more better because your graph looks very good, okay? But you guys, at least you guys need to do 10 data points, okay? But exactly the same way. So different angles, different angle of incidence, and you need to calculate different angle of refraction, okay? So let's try to save it, okay? Now, do you guys have any question at this point? Everybody's okay? You guys okay?
Yes, sir.
Okay, all right. All right, give me your response so that I can, make sure that you guys understood. All right. So, what is the situation? I'm taking the angle of incidence, the angle of refraction under what? Under air medium and water medium. So you guys need to remember that. Okay, so this is the air medium, angle of incidence I'm making, and the water medium is right here. So air medium, look at this. Air medium, you have index of refraction which is 1. All right, I mentioned earlier. So if it is water, then index of refraction should be 1. It's right here. So you guys need not to look at here. All right. So when you have air medium and water medium, so air medium should have the index of refraction which is 1. That is known, very known. Okay. But when it is water medium, then angle of refraction should be different. What is that different? All right. That number you can get from here, 1.33, that's the number. Look at this. So this is your air, this is your water. Water is slightly higher index of refraction. So this number, whether it is matching, all right, from the experiment or not, that is the job we need to do. So index of refraction by, doing the experiment, if we calculate and if that number is, same as this number, that means you can say, okay, I did the experiment correctly. All right, so it has to be 1.33. So let's try to see whether the index of refraction in water medium is 1.33, that is matching or not. Okay, that's the thing we are going to talk about now. So far we collected 2 angles, angle of incidence, angle of refraction. So now is the time to do the other things, okay, to making the graph and other things, okay. So let's try to go back here. Now, so this is your 10 degree, this is your 9.1 degree. So 10 degree, the first one, 10 degree, sine 10 degree, how much is it? Do you guys have scientific calculator with you? Anybody who got the calculator? So sine of 10 degree, how much is it? Anybody who can give me that number? Right, I did it. That number for me is 1.17, 0.174, I would say. Okay, so this is the 10 degree. So let's see how much is it sine theta 2. So 9.1 sine, you need to do 9.1 sine, and that number in my calculator, which is 1.158. Okay, this is the number we got. So let's say the second one, sine of 15, how much is it? So 0.25, let's say 0.26, I would say 0.8. So let's write it down, explicit one, 8. Okay, so 0.258, that's the number I got. 15 degree, sine 15 degree, right? Now sine of 11 degree, how much is it? 11 degree of sine, what I got here, 0.191. Okay, so that's the number I got. So let's try to do it sine of 25. 25 degree of sine, that we are getting 0.423. Okay, so that's the number I got. And let's try to do it sine of 20 degree. 20 degree of sine, that is gonna give you 0.34. I said 2, okay? So 3 digit I go. All right, let's try to do sine of 60 degree. That is gonna give you 0.866. All right, and let's do it sine of 41 degree. 41 sine, that is gonna give you 0.656. Okay, so let's do. Okay. So we got our numerical data. Okay, now is the time to plot it. How do you plot it? So what you need to do, sine theta 1 and sine theta 2, that you need to plot, right? So you guys know that sine, this is your y-axis, this is your x-axis, this is y-axis, right? So sine theta, that means you have to have, your sine theta 1 should be your y-axis and sine theta 2 should be your x-axis, right? So you guys need to make sure that, okay? So in this particular case, if I plot it, then what will happen? Let's see first, okay? So plot it, scattered, all right? And let's put it this way. All right, now let's try to do that one, okay? Okay, so this way, and you can put the, you can change the legend, right? So, okay, if you don't want that, so let's do it one more time, okay? Let's do it one more time. So insert, scattered, all right, let's do it with this one, okay? So, all right, that should be better. Okay, so let's try to do that one. Okay, so this is basically your data, okay? So you are getting a straight line, right? Now, what you need to do, you need to fit this one. So y-axis and x-axis, what is your y-axis, what is your x-axis, you have to make sure. Let's try to figure it out. What is that? The maximum theta 2, right? So theta 2 is 0.6, all right, 0.6. All right, so this is your, this is sine theta 2. So it should be x-axis and this should be y-axis. So let's do it this way. So this is not the correct one. Legend is different. So let's try to highlight, or you can do this way. So when you do that, so as this is the x-axis and this is the y-axis, so this is the x-axis, this is the y-axis. So x-axis, this data point should be here. So let's try to, do it this way. When you guys are doing that, initially, please try to think about that, which part should go to the y-axis, which part go to the x-axis. If you little bit think about beforehand, that will make your life a little bit easier. Okay, so let's try to do, this is your y-axis and this is your x-axis. Now, this is your y-axis, this is your x-axis. Now it's fine. Okay, so let's try to do it. Okay. You guys understand what I'm trying to do here, right? Just try to get the correct legend, y-axis and x-axis. Yes, this is perfect. Okay. I think, is it right? So this is your x-axis, y-axis, and this is your x-axis. Yes, this is perfect. So this is the way you need to figure it out. Okay. Now, this is your straight line, and as you know, that you have to go to this way. And if you don't need this straight line, then you can take it off, all right? If you want, you can take it. If you don't want, that's up to you. Now, when you get this graph, so unnecessary thing, please try to remove. And this is the graph you have. So it is, very easily I can say this is a straight line, okay, without any trouble. All right, so yeah, let's do it again this way. All right, so this is the straight line. Now what you need to do, you need to fit the graph to get the slope value, right? So how do you do that? Now you will get some sort of, when you do that, okay, it's right here, formula, data. Okay, so two different ways you can do it, all right? If you want to get the slope value, all right, let me try to give you one of the easiest trick. The slope value, when you calculate, then what will happen, m, which is equal to, you know, the maximum y over x. So slope value should be y divided by x, all right? That is the slope value, or y2 minus y1 divided by x2 minus x1. So you all should know, you know, that one. So if it is the case, what you can do, you can write this equation in this form, okay? What is your y value? That means this is your maximum value, right? So if you consider this maximum value, then what will happen, this is the data point we are talking about, right? So let's say, you know, this is your y-axis. What is the maximum value? Maximum value in this case, 0.65 and 0.8, right? So what is your y value? This is your x value. This is your y value. This is your x value, which is, all right, should be the top 0.656 divided by points 656 divided by 0.866. If it is the case, all right, then how much is it? Or you can do it by calculator to get the m value. So let's do it now. So with the formula, you know, you can write it this way.
Excuse me.
Do you follow me?
Shouldn't 0.86 be, that's your y value, right?
So this is your maximum value, right?
Of y,
6,
right?
This one, this point I'm talking about. So at this point, your y value and x value you need to divide. So this is your, you know, y value. So y value basically should be this one, right? Y value is this one, right? 0.86. No, I'm wrong. Yeah, it should be opposite. Okay.
Right. Okay.
So it should be opposite. Okay, you are absolutely right. Okay. So let's try to remove that. So manually you can do it without any problem. So this is your x value, this is y value. So y value should be, let's say, you know, 0.866. You can do it manually. 0.866 divided by 0.656. If you do that, then how much did you get? You know, this result should be exactly 1.32. Okay, 1.32. With my calculator, I got this slope value. Okay. So do you guys follow me? You know, do you guys confused or anything? Do you guys understand what I'm trying to do here?
Yes, sir.
Okay. So basically, what I'm trying to do here. So this is the slope you got, and we are trying to calculate the slope value. So slope value is always y over x, right? So y value, if you take any point here, any point if you take, or you can do it this way, y2, whatever y2 value here, the maximum value y2 minus the minimum value y1, subtracting and then divided by x2 minus x1. If you do that, the exactly same value you get, 1.32. Now this slope is basically the index of refraction of the unknown part. Okay, so this slope basically should be exactly equal to N2 divided by N1. All right, so that is the equation. So the whatever slope value you got, all right, that slope value should be exactly equal to 1.32 as I calculated, and which is equal to N2 by N1. Okay, so N1 is the index of refraction for the water. I mean the air, not water, air. So if it is 1, index of refraction for air, we all know is 1. So if you plug in 1, then it should be exactly equal to N2, right? So that N2 basically should be, N2 should be 1.32, all right? That is the value. So standard, look at this, in your simulation, your water value, I mean, when refractive index of water, you got 1.33. Now, by calculation, you got 1.32, right? So it's pretty much similar. So if it is 1.1, then it should be a problem, okay? If it is 1.23, that should be a problem. But when you got 1.3, other part, because of the error, when you are taking the measurement, eyes, error, when you are taking some sort of errors are there, right? So because of that, we got that much difference. So if you get this value, then you can get the percentage of error. How do you get the percentage of error? Very easily you can do it, all right? It should be like this, percentage error. You can write, the standard value, which is 1.33, minus the experimental value that you got, 1.32, and the whole thing you need to divide by, standard value, which is 1.33, all right? And, this thing you need to multiply by 100, multiplied by 100. So 1.33 divided by 1.33. So manually, if I calculate that one, with the Excel sheet, you can do it very easily. So 1.33, the standard value, minus 1.32, all right? It comes 0.01 divided by 1.33, whatever it comes, times 100. It's only 0.75%. So less than 1% error you have, all right? So what I'm trying to do here, let me write the formula very clearly. So 100. Okay. Okay, so this is the standard formula. So your the standard value minus, your experimental value that you got 1.32 divided by 1.33 times 100. So if you do that, that is going to give you, all right, the value. So you guys can, use the calculator and try to figure it out. In my end, it is 0.075% error we got. Only 0.75, not 0.75. It's less than 1% that I'm trying to say, 0.75%, which is perfect. So if it is 10%, 20% errors are there, but still you are absolutely correct. Okay, so this is the value that basically we got experimentally. So what you need to do, guys, you need to follow, the way I did and try to measure the index of refraction for the second media. So in this particular case, I used air media and, water media. If you are changing the water media to the glass media, exactly same experiment you can do, all right? And then you can calculate the index of refraction And that has to be like this. So if it is water media, then 1.33, we already got the result 1.32. If it is glass media, then what will happen? Look at this, index of refraction for the glass media should be 1.5, it is higher. So you definitely get that value by doing the experiment. All right, so one refractive index you have to know, then other you can figure that out. All right, so if you don't think that you don't want to use, for example, the air, so if you use water, all right, water medium, and then glass medium, you can do it, but water medium, all right, you have to know the index of refraction, which is 1.32, right? So if it is the case, 1.32, then that should be the known value. Then unknown value should be the index of refraction of glass. You can calculate exactly the same way. So these are theoretical value, right? So experimentally, how close you can get, that kind of experiment basically we are doing today. Does that make sense to you all? Do you guys understand?
So if you don't use air, the known, you just replace it where air was.
Mm-hmm. So what you can do, this is my suggestion, okay? Try to make everything easier. So try to use the ER media as the basis, all right? ER media index of refraction is 1, all right? Now, what you need to do, if you are bringing the ER media, ER to ER, look at this, the laser is straight passing through. That means index of refraction should be same, right? Because both are same media. Right. Now, if you change the water, all right, calculate the index of refraction of water, which is going to match with this number, right? As I mentioned earlier.
Yes.
Okay? So, first do this one. And when you are done, then try to change the glass. And exactly same experiment, same data you need to collect and try to figure it out whether the index of refraction of glass is same as this number or not. Same this number or very close to this number, and try to calculate the error. If it is within 10% error, then you are absolutely right. And you guys understand how do you calculate the error, right?
Yes, sir.
So standard formula for the error is the standard value, which is this one, minus the value, experimental value that you measured by the experiment, all right? Divided by the standard value, this one, times 100. And that is going to give you the percentage of error. How much error you have in your experiment. Maybe 5%, maybe less than 1%, maybe 1%, something like that. Okay? And very easy experiment, but when you collect the angle of incidence and angle of refraction, if you do it properly, then I think you should not have any problem. So what you need to do, your basis is the air, index of refraction. The index of refraction for air is known, 1. And then you measure the index of refraction of water, doing the experiment, collecting the data the way I explained. And water needs to be replaced by glass media and measure the angle of refraction, all right, and calculate the percentage of error. So that's all you need to do, okay, in this experiment. So what you need to do, just measuring the index of refraction per second. First refraction we know, second media you need to measure using the Snell's law. Okay, that's all. You guys are okay so far? Any question?
So we do the water, then the glass, and then we use Snell's law?
Yes, correct. So basically what I explained, that is based on Snell's law, okay? So using the Snell's law, we measured the index of refraction of the second media. So water is your base media, it's a known media, index of refraction you know, and with respect to that one, unknown media like water, you can measure the index of refraction. Unknown media like glass, you can measure the index of refraction. That's it. And then conclusion has to be, doing the index of refraction of air and the index of refraction of glass, which is perfectly matching with that, and how much percentage of error you got. For example, to measure the index of refraction for water, 0.75 or 1% error I got, all right, and for glass, maybe 1% I got, so Snell's law I used and perfectly measured the index of refraction, both mediums, with the known media of air. All right, so in this lab, you have a little bit calculation, all right? How did you calculate the slope value, y over x, or y2 minus y1 divided by x2 minus x1, I hope everybody knows the process, how to measure the slope. And that calculation you need to show after the data table, the way you did before. And your graph, all right, for the calculation has to be there, as I explained earlier. And then conclusion should be like this. And when you write the lab report, please try to use the handout that I gave you, right? That will help you a lot. And in your theory part, so first of all, you need to understand what is refractive index. That definition has to be there, all right? And in the handbook, that information you can find. And what is Snell's law, all right? How Snell's law is working, you need to explain that. And using the Snell's law, how do you calculate the index of refraction of the second media, okay? So you need to explain that. And the material used, basically how many components you used to do the experiment, you need to mention that. So first is the laser source and a protector. You need to mention that, and the materials, ER material or ER medium, water medium, glass medium. These are the materials he also used. Try to mention that, and then theory and the experimental graph. The way you did before, it's exactly the same way you can do. Okay. All right, so this is the experimental part. It might make you study a little bit. Okay, so there are other options. Those are not related to your lab, but what you can do, you can play with that. No harm for that. Play with that, and that will give you some confidence about refraction, reflection, how it works. All right. So please try to play with that. So if you press the prism, look at these different types of prism we have here, how light is passing through the prism. You can do some sort of hands dirty thing, okay? So if you turn a laser, look at how the laser is passing through it. And when laser is passing through it, this is in the air, right? So light is passing through straight. And when it is passing through prism, then refraction is happening here. That's why light is slightly bended, okay? So when light is coming here, again, light is moving straight because it is passing through ER medium, okay? So now, if you put the prism back, if you have some other type of thing, let's say other type of prism like this, it's the same thing you can see, you can observe that, all right? If you have circular type of thing. Look at this. This is the straight line. It's happening. The refraction is happening. All right. So if it is passing through a straight, still some sort of diffraction is happening here. So just play with that, okay? And try to get some sort of information from there. So look at this. When light is passing through, light is bending. All right. So this is the thing, you can play with that. Now, this is a single ray, all right? Even though it's not ray, but we'll consider it as a ray. As opposed to ray, if we are talking about beam, then what will happen? If you press this one, look at this is beam. So many rays are coming out. This is the beam, okay? So this is beam. And if you click this one, that is gonna give you a ray, all right? This is the single light showing the path of it. And this is another thing. This is just changing the background. That's it. Okay. And right, so when light is passing through, okay, this laser is passing through air, right? So this is the air medium. So look at this. This is the air medium, right? Now, if you are changing air medium to water medium, then what will happen? Look at this. So just change it. This is the water medium. So water medium is still the same thing. When light is coming from water, passing through water, then light speed will never ever change. All right. So you need to remember that. So when light is passing through the same medium, all right, then refraction will not happen. Refraction will happen only when light is passing through one medium to another medium. So if it is passing or coming in the same medium, medium, look at this environment is the air environment. So look at this, light is passing straight. Now if it is water, if it is one medium, all right, same thing. You know, laser is coming from the water and going to the water. All right, now if it is glass medium, look at this, the environment is changing, okay, but the laser is not bending at all, okay. So when we are talking about laser, then laser should have, you know, light. So laser is a light and it should have frequency, it should have wavelength, right? So if you are changing the wavelength, you can do it. If you are changing the wavelength, look at this, how this laser is changing. Okay, so let's try to do it. Look at this different color light we are getting from here. So let's say this is the blue color light, all right? So this blue color, it should have the wavelength which is 484 nanometer, right? So let's say if it is, you know, purple, you know, that is going to give you 380 nanometer. So if it is red, let's say how much is it? 700 nanometer. So with your, the color code that I gave you today, so that with your red is the highest wavelength, all right? And the lowest wavelength is purple, which is 380 nanometer. So from 380 nanometer, the wavelength is changing and they are going to give us different colors, all right? So when wavelength is changing, color is also changed, all right? So this is the way, you know, the light is working. So this is the one thing you can see if you want to see how reflection is working, all right? So you can check this one, all right? So, all right, like this, if you are changing the medium, then what will happen? Okay, so you can see that way. And you know, if you have a protector, you can measure the angle, you know, as we did before, okay? And what else? Yeah, that's it. So most common thing is this one. So if you want to see the reflection, if you want to see how reflection is working, all right, just turn on the laser and reflection and refraction is happening like that. If you wait, then look at this, how it works. So, you know, light is a transverse wave, so as we talked about today. So when it is transverse wave, then it is moving, you know, like this. This is a waveform. And if it is waveform, then it should be like this, okay? Okay, so if you are trying to know, right, something that is related to index of refraction, as I mentioned earlier, the index of refraction basically when light is passing through a medium which is harder, then the speed of light is changed, right? So let me try to check it, whether it is right or wrong. So this is the air medium, okay, we can see air, and this is the glass medium, okay? So this is the glass medium, this one. So this one is lighter, less dense media, this is the dense media, right? So let's see how much wavelength or speed we have for this laser. Look at this, we can measure it. Speed, this is the speedometer or a speed meter. So let's say if I put the meter right here, this is the speed of light, which we all know, 3 times 10 to the power 8 meters per second. So look at these, 1 times c. C means 300 times 10 to the power 8 meters per second, which is right. Okay. Now, if you bring that meter right here, look at this. So 40%, so 67%. All right. All right, so 67% C. That means 3.00 times 10 to the power 8 meters per second times 0.67%. Approximately more than 30% of the speed is getting down. 30% of the speed is getting down. Here is 100%. So 1 meaning 100%, right? This is 100% speed of light. Now, when you are coming here, it's approximately, all right, 30% or, yes, 30%, more than 30% speed of light is getting down. That is why bending is happening. So look at these, right? So if you are changing it, but it doesn't change the speed of light here, as long as they are inside the, the glass medium, all right? But the speed is changing 67%. It was 100% here, but 67% here. So more than 30% of the light, you are losing, speed is losing, okay? Now, in terms of intensity, you can see that one. Okay, this is the time, okay, we don't need that. All right, so let's say intensity of light. So intensity of light, if you put it here, look at the 100% intensity, right? Now, if you bring it down and look at this, if you put it here, the intensity is also changing, okay? Because the speed is changing and intensity is also changing. So here is approximately 90% of the intensity here, and whereas your intensity was 100% here. Now, as I mentioned earlier, the partial reflection you can get, if you have two types of boundary, two types of medium. So look at this, how much intensity we are getting here. So let's only 10 point or 11% approximately, 11% of the intensity, will be reflected like this, all right? And 90% of the intensity, all right, we are getting here. So these two, some of the intensity losing by reflection, and most of the intensity we are getting by refraction, okay? So altogether 100%. So here is 100%, here is, let's say 30% lose, and no, not 30%, 10% lose, and 90% here, okay? So this is the way you can also measure that intensity very easily. So you can play with that, okay? About the reflection and diffraction, how it works, okay? But as long as your experiment concerned, that we already explained that air medium is the basis, and change the water media and the glass media and measure the index of refraction and calculate the percentage error, right? That's it for this experiment basically. So, do you have any question, any concern?
Could you repeat what you wanted for a theory? It broke out.
Okay. Okay, so in terms of theory, right, that you were saying?
Yes, sir.
Okay. So, when you write the theory, all right, go back to the handout that I gave you, right? So, first of all, equation 1, you need to explain a little bit. So what is index of refraction? Okay? And then try to talk about Snell's law. So this is your Snell's law. Okay? Snell's law, describe this one, equation number 2. And how do you use this equation to calculate the index of refraction, all right, of the second media? So in this case, this media is air media we used, and this media is either water or glass, okay? So talk about the Snell's law, all right? If you want to Google it, you can do it, get some ideas about it. And after that, the Snell's law, when you discuss, then this is the equation is very important. Based on this equation, okay, so you are calculating the index of refraction of the second media. So N1, the first media is known, so second media you can get sine theta 1, sine theta 2 that you are plotting, is right here, and get the straight line, all right, talk about that. So what I'm trying to say, whatever we have here, equation number 1, 2, and 3, talk about that, okay? And equation number 4 is the equation for the straight line. You can fit this curve, or you can manually calculate the slope value. So it should not be a problem. And this is the data table. And when you are analyzing the data, then read this part, and that is going to give you some.
Thinking about this.
What did you say? One more time, please. I'm sorry. Any question? Okay. So Nathan, you are okay?
Yes, sir.
Okay. All right. So yeah, that's it for this lab. And as I mentioned earlier, that lab report due date should be on July the 20th. All right, July the 20th. What time? Time. I did not give you any particular time. When you are done, you can upload it. No problem for that. All right. And July the 16th, that should be your exam 2. All right, on chapter 19 to 22. All right. So please try to make sure. And I'm going to upload the study guide. All right, as I mentioned earlier. And try to study on that, and hopefully everybody should be fine. All right. So, do you have any other question or any concern before ending the lab?
No, sir.
Okay. So then, basically, then we are done for today. So, before leaving, I think I did not take the attendance, right? Yeah, it's fine. So I'm going to give you full attendance because everybody were present. Okay, so no problem. All right, so that's it for today. See you on Tuesday, okay? See you on Tuesday. And Tuesday, basically, we are going to talk about chapter 23 or chapter 24. So that chapter basically will not include it. All right, let's put it this way. So that chapter will not be included, okay? So chapter, whatever chapter we did on exam 1, from there up to chapter 22. So I'm gonna, give you questions on that, okay? All right, so that's it for today. So see you Tuesday. Thank you.
Okay.